So the last lecture was all about motional EMF. We saw some of the basic derivation of motional EMF, and today we are going to extend the same thing. So today we are going to apply that idea to derive the motional EMF in various moving bodies. When I say various, it means it may be translating, it may be rotating, it may be performing combined motion, it may be oscillating. So in every context, we should be able to find the EMF induced. Okay. So we have seen the translation part. Okay, what happens if a rod is translating, and we have seen the translation in if it is kept in a uniform and transverse field. So what if the field is non-uniform? So imagine we have infinitely long current carrying conductor, a straight conductor, and we have uh, a wire. Of certain length, and this is moving at a velocity v in its direction perpendicular to its length, and the nearest point of the length is a distance away, and the length of the rod is L. So we are supposed to find the EMF in the rod. So what will be the answer? Try this out.
Sir, can you just come back in a minute?
Yeah, sure.
Sir, I don't understand how the magnetic field is variable here.
So due to the infinite wire, we know how B will vary, right?
Okay, yes, sir. Non-uniform acid.
So what you have to do is you have to take elementary part at certain distance away from the wire and then find the EMF in that part and then integrate it. That's simple logic, right?
Yes, sir. Sir, but the flux does not vary with.
No, we are finding the motional EMF. No? In motional EMF, there is no flux. It is, imagine like the field lines are like vertical, like normal to the plane, and this is like a knife. The rod is like a knife cutting it. You are intercepting it. Okay. So we are
Sir.
doing the motional EMF. We are not doing the flux. I hope that the motional EMF, you can just go through the PDF which I have shared and try to understand what happened in the last lecture.
Yes.
Yeah.
So,
Yeah.
sir, is it mu naught bi by 2 pi ln of a plus L by A?
Correct. So we have to write the DE formula. The DE motional is B V dx, right?
Yes.
So from the x distance away from the wire, we have a small elementary, and the velocity of this elementary is still v, right?
Yes.
So the motion of is bvl, but L is dx. And why we are writing this way? Because B is a variable quantity. And for a small distance, we know it will not vary. So this we can write as a mu naught I by 2 pi x. And we have seen such kind of derivation in past also, right? Yeah. Okay, done. Na?
Yes. Yes.
So now let me extend this problem. So again, we have a square loop, as you can see, and the loop is moving with velocity v normal to the wire given to us. What is the total EMF in the loop? So total means you can find the answer for each part and then add it accordingly what you can understand. So try this question. Got the answer?
Doing it. Sir, I'm getting some mistake in forming the equations.
See, if you look at the left vertical parallel bar, the entire bar is at same b, same distance, right?
Yes, sir.
And here x is not variable. X is x is variable, but it is as a limiter variable. Okay. So when you solve the question, you will take elementary at some new value called z to dz, right?
Yes, sir.
So you can go at z from here. And cut the elementary dz length. Okay, this is not required for. Now let's call the part. If I talk about this part, for this part, the b is same, everything. Okay. So because v is same, so EMF will be how much? B cross V, V cross B. 1, 2, 3, 4. See, 2 will create a B 0. I mean the EMF in the E2 is E4 equals to 0. Why? Because these lengths are parallel to the velocity, isn't it?
Yes, sir.
So that part we have to do nothing, in fact. And therefore, you have to find for 1 and 4. That's 1 and 3. So what is 1? B, V, L. That's it. What is E2? B.
Yes.
And we can substitute B1. Why we are writing B1? Because the entire B is same for all the bar, right? For the segment, the B is same, isn't it? So B1 is how much? Mu naught I by 2 pi x. And therefore, the direction of battery, this will act as a cell like this. And in the loop, these two cells will oppose each other because they are facing the plus to plus. isn't it? The net EMF will be how much? The big minus small. Understood?
Yes.
So now is this clear?
Yes, sir.
Not clear? Understood? Yes or no?
Yes, sir.
So so imagine we have a rail like this. I hope you remember the rails.
Yes, sir.
You may connect somewhere register. And over this rail, this rod is sliding at constant velocity v. So what will be the induced EMF when it is at a distance x away from it? Find emotional.
Yes, sir. So it to be the extent.
Yeah. So the L will become how much? We have to find L. So tan theta is L by 2x.
Yes, sir.
So the emotional EMF will be B. Okay, B is here given is constant. So I forgot to mention B. B is constant. So BV is the right answer. Okay.
Yes, sir.
So let's do something from Erodub. All questions are very easy. Just you have to think this way. Come to the page number 147 of your Rudolph. Solve question number 3.288. Solve
So 2b under root y by ab.
how much you got? 2.
Oh, it's moving with a constant but acceleration.
Yeah,
Just
acceleration is constant. You have to find the v as a function of displacement.
yes.
So do it.
So 2b under root y by omega t.
Check the answer. The omega is like acceleration, right?
Yes. So the variable t is not allowed. So I have to convert it into terms of displacement.
Correct, correct. So that's easy, no? You know how to use it. In
Yes,
kinematics,
sir.
use the third equation.
Yes, sir.
Yeah.
Yes, sir. Got the answer.
Very good. Okay. Next, you can solve this question. So actually, you can create any sort of mathematical graph, and you can apply the same logic to get the answer. So if you remember, long time back, we had solved one question of a circular field, right?
Yes, sir.
So we had one circular, or you can say cylindrical region in which the field was present, and other was the circular loop of same radius moving with velocity v, and this entire region. So now this is b, and it is entering this field. The radius of both are r. And if I say this is t equals to 0, then find the EMF induced as a function of time t. So tell me the answer.
Sir, I'm not able to, so I considered theta in my calculation, but I'm not able to eliminate it.
No, you have to simply see whenever there is a conductor in a field, we look for the gauge length, and once you are able to see the gauge length, you can write the formula BVL. That's it. So we have to find the, and for any curve wire, what we do, we take the displacement. L is what? The beginning and the end, right?
Yes, sir.
So we are not bothered about the shape actually. Once you move inside, let's say if you move inside by VT, then okay, of course, if you draw it, you get it. It is like you just need to understand a bit of circle, and that's done. So it is like this. It goes this way, right? So what we are concerned about is not this length. I just want this length.
Yes.
I'm done. And I know this length, right?
Yes.
Because I know this length R. I know this is R minus VT. So how to find this one? Pretty simple. No?
Yes, sir.
So what is AC? I mean, use Pythagoras. Why you're trying to find using something else? So R square equals to, that's it. So what is Y? So the induced EMF is B, V, and L is 2Y. That's it. So 2BV, and this is A plus B. 2 minus 50. That's it. I hope this is clear.
Yes.
And this we apply for when VT is so up to T less than. That's it. Because the the definition should be correct, right?
Yes.
Okay. So we have seen like a translation with a transverse field, and we have seen translation with transverse field in which the field was constant and the field was variable. So what about translation with a non-transverse field? So if we have a rod and the length is L, So I hope you can see it. And let's say the velocity vector is parallel to the y-axis. So can we find the EMF index? Yeah.
Sir, DL sin alpha sin beta B.
You mean to say V L sine alpha sine beta be like this? You're saying?
Yes, sir.
Okay. Okay. So let me tell you the answer. It's L cos alpha. Cos alpha.
Sir, but B cross B is in minus Z direction, so we have to take the component of L that is in minus Z direction, right?
V cross B is in the minus Z direction, correct? And that is equals to L sin beta into cos beta. L sin alpha into cos beta, right? The best way to solve
Sir,
is
cos beta or sin beta?
because
Because we are taking that blue line, which is
yeah, the best way is write the vector form.
yes,
So V j cap B I cap dot and the L we can write as L cos alpha j cap
yes, sir.
L sin alpha cos beta I cap L sin alpha sin beta k cap. That's it.
Yes, sir.
So V B and J cross I is minus K. Okay, so we are taking this way, but that's okay. We can take eventually mod. So V cross B, something like this. So V cross B dot and only we have to take the K component, right?
Yes,
The
sir.
rest will be zero. The answer is correct. It's VBL sin alpha sin beta. Correct. Very good. Or the way we could have done is uh, the length which is perpendicular to the velocity vector is the bottom one. It is L sin alpha, right? This is, so the shadow is L sin alpha, right?
Yes, sir.
And the component which we need normal to the B vector is L sin alpha sin beta, right?
Yes.
And then velocity is like this. So now everything is mutually perpendicular, so we can write the answer directly for sure. E motion as B V. Okay. And then V cross B will give you, this is at high potential, this is at low potential. This means this shadow means this is at low potential. Correct?
Yes, sir.
All right. This is like challenging problem. So imagine so now motional EMF So what if we have uniform and transverse field? And let's say this is the rod. And this rod about one of its end is rotating with constant angular velocity omega. So here in the formula of BVL, the issue is B is constant. But as you move across the length of the rod, V will vary, correct? So again, we cannot apply BVL. What we have to do is we have to apply the elementary formula. So we are at D equals to BVDL, and I hope you know how to solve it, or dx or whatever. So can you find the net value of motion EMF? How much you're getting here?
So B omega L square by 2.
Yeah, that's correct. So it is B, you can say omega x dx. Let's say you move x and you cut a dx. So this dx element is moving with velocity v, and this v is omega into x. And for this entire dx length, we know that velocity is going to be same. So okay, in this calculation, we ignored something. So the next two questions that we're going to solve is from which is like a theory, but which we call centrifugal EMF. Imagine we don't have any magnetic field, we just have a rod, and it is being rotated about its end at a very high frequency. Let's say the length of the rod is really small, and we can achieve millions RPM, or maybe yeah, millions RPM is good enough. And we know that in the rod we have the free electrons. Let's say the mass of electron is me given to us. So what we are supposed to find is find the E induced as a function of R from the center. So at a distance R from here, what is the induced electric field value? This is what we have to find. And once we have got this answer, find the motional EMF, or so to say centrifugal EMF. Of course, left hand. So think about it, what I'm saying. So centrifugal force will throw the electron towards the right hand, isn't it? If all electrons are thrown to the right, it will also create the polarity, isn't it?
Yes.
So at equilibrium, what will happen? The centrifugal force is balanced by the electric force. Otherwise,
Yes.
electron will keep on going towards the right hand, isn't it?
Yes.
So think about it and tell me the answer.
So,
Yeah.
sir, mr omega square by E.
Yeah, something like that. So if you think the electron will accumulate here and the plus charge, so every electron will experience the electric force in the left and uh, centrifugal force like this, correct?
Yes.
So for equilibrium, it is E equals to, correct? Isn't it? This is the force, no?
Yes.
And now the E, yeah, I would say centrifugal EMF equals to, you can write E dot dl, write the value E dr, and correct.
Yes.
So this is the value. So we saw the first answer where we ignored the centrifugal effect. In the second, we ignored the magnetic effect because I never introduced the magnetic field at all here. So the third case will be when we superimpose both situation. So what if we have the magnetic field? as well as what if the omega is high enough to create the centrifugal effect. So now if I choose this to be cross, what will be the direction of magnetic force on the electron? If you think of any electron, the force will be into the or
To
towards
the
center, right?
direction. Yes.
Yeah. So magnetic force will try to bring it inside,
Yes.
whereas the centrifugal will try to pull it outward. So, so the magnetic force we can write as Q V B at any distance R.
If you
Q,
take the electric field also into account, right?
pardon? No, no,
Sir,
electric,
the electric.
in the very beginning, we don't have electric field, right?
Oh, yes.
So V cross B is inside,
Yes.
whereas the centrifugal force is outside, M omega square R. So you can see the net force we can decide in the very beginning. So if Q omega B exceeds the M omega square, because R is common. So basically, if QB by M exceeds the omega, because QB by M is called the magnetic frequency, right? Omega is very famous in the magnetism also. So if I choose the angular frequency as we saw in magnetism, if omega naught is more than omega, it means the electron will move inward. So the center of rotation will be at low potential and the extreme will be at high potential, and vice versa. So what I'll suggest is solve for this particular scenario. The reason is the motional EMF due to the magnetic field is quite dominant compared to the centrifugal. In fact, centrifugal is so small compared to the other one that it is almost nothing, tending to zero. Okay, so now you're supposed to find the net EMF. Can we do it now? So what is the EMF motion? So the same process, after some time you can choose the induction and then you can also represent the electric field and then write the net field. Okay, so do it.
Sir,
Yeah, tell me.
sir, but wasn't this what we had solved like 1 or 2 questions back?
Yeah, so you have to solve like that, but you have to take the electric field, then integrate the E dot dl to get the net EMF, because one will try to create the EMF left, other will right. So in a way, they will cancel out each other, right?
Okay, sir.
The
Yes,
way the way it will try to move the electron is different, na? Correct?
yes, sir. There we had taken only QVT, but
Yeah, yeah.
oh,
And here, if I change the field as dot field, the electron will also go right, and centrifugal is also right. So you have to take multiple cases actually. The case when the two forces are opposing, the case when the two forces are supporting. Okay.
so here we have to take electric field also into account.
Yeah. Of course, electric field you will take at a later stage when the induction has taken place. So E will be there, no? Because
Yes, sir.
without E, there is no EMF.
Yes, sir.
Understood? Yeah.
So, but then in the initial stage, it will just be Q NT omega L square by 2.
Correct. Correct. That is that T equals to 0. I mean, but see, the electron will go in no time. So the moment you start, it will go.
Okay.
It won't take the time that we are thinking. It will take just a nanosecond to accomplish the task. It is like the moment you start it, it will happen. It's over.
Okay.
Yeah.
Uh, sir, when QBM, sir, like when the magnetic field, one second.
When the magnetic force is dominating, right?
Yes, sir.
Yeah. So in that case, the answer will be here in this case.
So in that case, it will be d omega minus
Yeah. See,
omega
one force will write as QVB,
Yes, sir.
other will write as M omega square R, and because see, we need to choose something like E is either left or right. So if I assume all because of this Q force is dominating, if all electron will come on the left side, then positive will develop here, right?
Yes, sir.
So the field will be like this.
Yes, sir.
So force will be like this
Yes, sir.
because we know that electron is negative, so force is left. So what you get here is E times E equals to so E turns out to be Q omega B. Oh, 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 oh. This is E itself.
Yes, sir.
Just a moment. So the E becomes omega B omega R minus M omega square R by E. And see, these are like superposition formula. Like we have seen this formula before. So the motional EMF will be E dot dr. I will take the value itself. So the first term will give you B omega L square 2. Second term will give you M omega square. Okay. And now you know that this is just like superposition. But this formula we took for the one particular case if I have no restriction on the nature of B. If we take a B either inward or outward, so what if I switch the B? If we switch the direction of B
Its direction will also change.
in previous case, then the net E will be the summation, right?
Yes, sir.
So E into A is B omega R. What was that? Plus, so E becomes so the emotional EMF can have the answer plus also. So if B is not given in terms of direction, whether it's dot or cross, so I can say the E max we can get is and E minimum we can get is so the delta E, the max and the mean difference turns out to be M omega square L square by E because the 2 and 2 will add up, correct?
Yes.
So the difference is due to the centrifugal only. And if we don't have a difference of maxima and minima, then it means centrifugal is playing no role. Understood?
Yes, sir.
So let's take some other scenario. So again, we are supposed to rotate not just a rod but any shape object of any shape. Let's say we have so imagine we have this the rod is like this. Okay, so what is the induced EMF in this case? So omega is given, so it is half b omega L square, but L becomes, that's it. Okay, so we have to take the displacement and then do the answer. Okay, that's easy. Okay, next question. The next question is so we have transverse field and okay, we have a rod in the shape of L alphabet, and it is rotated with the help of one of the end, and you are supposed to find the induced EMF in the AB part. Find induced EMF I mean say motional EMF in part AB.
So it will be zero, right, sir?
Pardon?
So it will be zero, right, since along the length, the velocity is always present in AB.
No, if you choose any element, if you choose any element in AB, the V vector will be at angle, not parallel.
Oh,
Just draw it. No? Draw mathematically. Take any
yes,
point, small portion.
yes.
So while calculating, you have to take the component which is perpendicular to the rod AB part, the elementary which you have to get.
Okay, sir.
Hmm.
Huh?
Yes.
30 seconds.
See, for any difference, that simple trick is, if instead of AB, you can find for the OB, that too
Yes,
very
sir.
easy. So the EMF of O, I mean B with respect to O will be how much? Half B omega root 2L whole square.
Yes,
Because
sir.
for the entire rod, the displacement is root 2L, right?
Yes, sir.
And we can do it for the AO separately. If I consider only rod from the O to A, the answer is known to us. Correct?
Yes, sir.
So what is from A to B?
We could just subtract like that.
Yeah. So let's make it B to A, or so we only find the center of rotation to every other point. And if center of rotation is known to you, the distance from there to the end will matter, not the shape. So it is again, I think same answer, right? Half B omega L square. Correct?
Yes, sir.
Now, what if you want to do it by basic method, really scratch? So imagine an elementary portion here. If you take a small part here, the V vector here will be at this angle, a right angle to the radius vector, isn't it?
Yes, sir.
So can write as V equals to omega R. So we want, let's say this is X. So the induced EMF will be B V sine theta BVR, BVL, right? DX. Is this correct? Understood.
Yes, sir.
So we can write as B and V we can write as omega R.
Yes, sir.
Now, fortunately, R sin theta is how much? What is R sin theta?
L.
It is X
No, no.
itself, right?
Yes, sir. Yes, sir.
And then DX. So we can find the EAB equals to value wise. Correct? And that's why the answer is same. So there are two methods. Method one, which is very easy, but you can do it from scratch also using the same technique. I hope this is clear.
Yes, sir.
So if we design a rod which is connected with something like this. This is L, this is L. If I say this is 60 degree, so even though I haven't joined, but this is also going to be L.
Yes, sir.
So if it is rotating with omega about this center in a transverse field, then both end A and B are having same distance from the center of rotation. So A and B must have the same potential
Yes, sir.
without solving. And therefore we can say the EAB equals to 0
Yes.
directly. I hope this is clear.
Yes, sir.
Okay, so we have seen the rotation, we have seen the translation, so the time has come to do the combined motion. Okay. But therefore, I mean, there was a question from JEE-Mains, I remember. A rod with a insulating part attached. So maybe this is a wooden rod. So OA part is insulator. So we know that EMF will be developed only in the conductor part, not in the insulator part, right? So what is the EMF in the AV part?
Sir, 4b omega L square.
How much?
Sir, 4b omega L square.
4.
Uh,
So we can find from O to B directly, right? Half, yeah, that may be half B omega 3 real whole square, right? Minus.
yes, sir.
This is what you did, right?
Yes, sir.
Yeah, yeah, that's correct. Very good. So now we can go to the next one. Uh, Combined motion means the body is translating as well as rotating. Okay. So if a body is performing both motion, then how to deal with? So for that, we'll draw a plane. We will consider the plane as a conducting plane. And it is performing pure rolling motion. Pure. So there is no slipping. So if even if I give you V, you know that the omega and V will have the relation. So V equals to omega R, right?
Yes.
Before we solve this question, we'll do one small exercise. And that is, if I choose any 2 point on the periphery, from center, how far they will be? Same distance, isn't it?
Yes, sir.
If I choose any 2 point on the periphery, it will be equidistant from center.
Yes, sir.
And we know that in the CM frame, it is pure rotation.
Yes, sir.
And because the 2 points are having same distance from the center, they must have the same potential with respect to center. How much? Half b omega L square. Understood?
Yes, sir.
So imagine this way, like if I draw a rod, let's imagine some hypothetical or imaginary rod inside this, some rod like this. I'm not talking about the actual motion. I'm talking about the only rotational motion that we can see from the CM frame. So in the center mass frame, this rod will only turn round and round, isn't it?
Yes, sir.
In CM frame, it will rotate. Okay, so
Yes.
imagine this way. Go to the center of the rod. Yeah.
Huh?
If you go to the center of the rod itself, imagine the center of the rod. The center of the rod is rotating with omega, because we know that in case of rotational mechanics, the omega of a body is unique. So if the omega of this ring is omega, the angular velocity, what will be the omega of the rod which we have drawn as a red line? Omega only, right?
Yes, sir.
And if someone is at the center of that rod, what will be the potential of its extreme end? Okay, I think this is also complex. Okay. Think of this. Imagine a rod, and this rod is turning about center. Okay. So with respect to center, the EMF of the A will be how much? E of A with respect to O is half B omega L by 2 square.
Yes, sir.
And it is same for the half B omega BO.
Yes, sir.
So what is the AB?
Yes, sir.
See, from center, the two ends will have same potential. So if you go from center to center, I mean edge to edge, if you represent the each half rod by a battery, the battery will look like this. B is inside, so V cross B will be upwards. This is the battery, and this will be battery for this part. Can you see the battery are oppositely, I mean having the opposite polarity, correct?
Yes, sir.
So if you move from A to B or B to A, the net rise and drop will be 0, correct?
Yes, sir.
So the net EMF will be 0. That is the whole idea. Okay.
Sir, but here if I okay, sir, if we consider in the CM frame, means it will be like rotating.
Yeah, it is only rotating. So the
Yes.
whole idea is, if a body is performing combined motion, then the rotational effect will create a 0 value for any part of the rod, no matter what.
Yes, sir.
So at the end, only translatory part will matter. Okay. So the other way of thinking is, this. If I choose the bottom as the point of reference, then we know for pure rolling motion, the bottom will act as the instantaneous axis of rotation.
Yes, ma'am.
So you can think this as a omega and everything as a rod. So you can see there are two half circle. If I choose the point A, which is the topmost point, let me remove this. So how far is A from the center of rotation? You can see it's 2r away.
Yes, ma'am.
So EAO will be how much? Half B omega. And why we are writing this? Because about the IAOR, we only have rotation, so we need not to bother about the translation. So this question is as good as the question that we have solved before. Which question?
Sir,
The
one half
yeah, the rotating rod question.
Yes, sir.
So every question of pure rolling can be solved with the help of IAOR, because we need to consider only rotational motion, not the translation, and therefore we can find the potential of any point from the O. So to find the difference, you find 2 times calculation from O and then take a difference. Let's say if I choose a point B here, so EBO will be how much? Half B omega. So if someone is asking you what is the A and B difference, so of course B is farther, so B will have high potential. So I will take EBA, and the answer will be 4 minus 2, which is 2, right? 2 by 2 is 1.
Yes.
Which is same as B omega R square, right?
Yes, sir.
Okay. Okay, then so we have a conducting rod of length L, and we have done this question before. And this entire system is submerged in a transverse manifold. So find the induced EMF in the rod A and B. At an instant when angle is theta.
So, sir, are you there?
Oh, sorry, yeah, I'm there.
Sir, should we take it into account? Should we take the velocity of A also into account?
That
Perpendicular.
is not required. I mean, omega is sufficient, and then express omega in terms of V naught and theta and L. We have done this before in the rotational dynamics chapter, right?
Yes, sir. Omega is equal to V naught by L sin theta.
Excellent. So now you know the IAOR, right?
Yes, sir.
The whole idea is once we locate the instantaneous axis of rotation, then that is like the virtual center
Yes, sir.
about which it is performing pure rotation. So to find EAB, we can find about O to A and O to B, right?
Yes, sir.
So this is equivalent of writing EAO minus EAB. That's simple. And we know the how to find the answer from there. Half B omega. How far is A from O? L
Sir,
cos
L
theta.
cos theta. Yes, sir.
So we are done, right? It is B omega L square by 2, and cos square theta minus sin square theta is basically cos 2 theta, right?
Yes.
So the EAB turns out to be, and omega we can write as V naught by L sin theta. We have done this before in the chapter of rotational dynamics.
Yes.
Okay.
Yes, sir.
So today I will stop here, and I'll add few more conditions in the next lecture. So you will see some more examples, and after that we are good to go with the circuit problems. Like the real application is to use these EMF values in a circuit. So every circuit will have one part which is called the EMF calculation, and the rest is like Ohm's law and various analysis which we have done so far, like mesh, nodal, and all. And the other part of question that you will come across is like simply analyzing the motion of the moving rod. So it's like laws of motion and kinematics. So we'll divide the question into category, and we'll attempt one category at one time. So it will be lengthy chapter, so it will take some more lectures. Hopefully, you may expect 4 lectures more before we finish this chapter. Okay, so 2 more weeks.
Okay, sir.
So by keeping some extra lecture, we should be able to finish it early. Let's hope so.
Yes, sir.
So when is your examination?